This is Rick Haskell. In our previous segment, we took a look at marginal product of labor. So now let's take a look at total product of labor. I've given us here our marginal product of labor change equation. So marginal product of labor equals a change in quantity divided by some change in labor. And I've given us the table that we've developed to this point, including the marginal product of labor column, and replicated the marginal product of labor graphic for us in slightly better form than you see it when I do it with my handwriting. But now I want to think about this in respect to the total product of labor. So total product of labor is going to be accumulating these marginal product of labor values. And so we're going to see a graphic that gives us on the x-axis some level of labor, and on the y-axis some total product of labor. Well, the total product of labor in this case is going to be synonymous with the quantity column that we have. So let's just go ahead and graph total product of labor and labor, so that we can see what our curve ends up looking like. So at 1 unit of labor, we had 15. At 2 units, we had 35. At 3 units, we had 45. At 4 units, we had 50. So it looks like we're beginning to develop a curve that is increasing at a decreasing rate. At 5 units of labor, we similarly had 50, so our curve is flattening out, of course. At 6 units of labor, then, our curve begins to decline, and we're back down to 45. So we see a curve that is plateauing at the quantity of 50. And so when we think about the total product of labor and marginal product of labor, we want to stop producing at the point where the marginal product of labor has reached its apex. So we want to stop producing just before that point. We don't want to breach that point. Well, in this case, we don't get any additional benefit from this 5th worker. So there's no reason in going ahead and incurring the cost of that 5th worker. So what we've got is a relationship that puts these two total product of labor and marginal product of labor graphics in line. It's going to look something like what we've got here on the right-hand side. Notice that at the quantity of 5, we've hit a 0, and that is the same quantity at which we begin to decline. If we look at this, we can see that at that 5, we have now reached the apex of our curve, and we're beginning to decline. This also informs us a point where the slope is equal to 0. So we don't want to go beyond that point. There's no sense in increasing our labor units just so that we can decrease our units of total product. In fact, in this case, reasonably, we would prefer to stop here at 4 employees at 50 units. Our marginal product of labor got to its lowest just before reaching 0. Now, in many cases, you're actually going to bracket this such that 0 will have been between maybe 1 unit of labor and another, in which case you'll stop at the prior level. What we're looking for is some kind of profit maximization. And you'll see soon in some of the other segments that profit max takes place where marginal revenue product of labor, which we'll talk about in a moment, is equal to the marginal expense of labor, or is equal to the wage, which also then means that marginal expense of labor becomes equal to the wage. This is referred to as a general solution, whereas either of these are referred to as competitive market solutions or conditions for profit maximization. And we'll talk about those more in the next segments.